This is a tutorial for the 3x3x5 Cuboid, and it's one of the shape-shifting puzzles, which is why this is a little bit difficult. Okay. So even when you're mixing it, if you want to mix it very well, then you should always try to mix without changing the shape first, because once it changes shape, it becomes harder to separate certain pieces. Okay. Okay, so the first thing to do would obviously be to solve the shape. But right before we do that, there's something else. It's part of solving the shape, but you have to do it in a certain order. So, as you can see, the way it moves is basically a regular 3x3x3. So you can see there's always going to be a 3x3 side on every face. And the pieces that are on the orange and the red side have an extra layer. And those layers cannot move until the shape is complete for that side. So I'm going to take this orange and this red side as kind of an axis, and I want to solve for the edge pieces that go around that axis. So this would be the top and the bottom, and I want to solve for the middle layer first. And that's only because while I'm solving the shape, these pieces are the only pieces that will fit into this middle layer correctly. But at the same time, once you've put it in, the only way to flip it around would be to change the shape at the top or the bottom. So I want to put those in correctly first. So as you can see here, I have a green and white edge piece, but it's put in incorrectly. I had to rotate this. So I'm going to take this out to one side, and now I've matched up the greens, and I solve for that piece. And then I see a green and yellow here. That one goes over to this side. So move that up to the top. The yellow's on the bottom. So I'm going to match the two yellows. And I solve for that edge piece. At the same time, I also solve for the yellow and blue edge piece. And now all that's left is this white and blue edge piece, which is over here. Okay, so I have to take this blue, match it up with this center. And my middle layer is now complete. Okay, now with this, I can move on to solving for the shape. So without trying to make sure you don't mess this up, I'm going to try to solve for the shape. So at the top, for example, you can see that the cross, if I take these two pieces and think of that as one edge piece, if I flip that around, then I'm essentially solving for the cross, because if I flip this around, this piece will be like this piece. So it'll be in the correct shape. So I'm going to use a 3x3x3 algorithm to rotate these edge pieces and flip them around. So keeping them on the top, I'll do F, R, U, R inverted, U inverted, F inverted. And as you can see, two of these were solved. And flip it around, and I'm going to solve for the rest of the cross. Now from here, I had to do that algorithm twice. So a slight shortcut would be F, R, U, R inverted, U inverted, and instead of doing F inverted, because I'm going to have to do F again anyway, I'll start from here, and I'll do R, U, R inverted, U inverted, F inverted. And I've solved for my top cross. And you want to solve for these crosses first. So now flip to the other side and see if there's any left. in this case there aren't. So now I can move on to solving the shape for the corner pieces. So again, think of both of these pieces as one corner piece, and I just have to rotate this. So for example, this one has to go counterclockwise, then it'll be in the correct shape. So there's several different ways of doing this. You can use the 3x3 algorithm for rotating these three like this, like rotating their positions, and the algorithm I use for that, usually, that algorithm will actually rotate these as they swap positions. Or another method would be to use an algorithm that's primarily used for rotating the corner pieces in their place. So that one's usually a bit longer, so I'm going to go with the algorithm to rotate these pieces. So I'm going to take this piece, and this piece, and turn them clockwise. So if I'm rotating these three, then I want the one piece I'm not moving to be on the front and the right, since all these are going counterclockwise. So from here, I'll do L inverted, U, R, U inverted, L, U, R inverted. And that's solved for all three of them. Okay, now when I flip to the other side, I see there's only two left. And the algorithm I just used always turns three of them, so there's no way that I can use just that algorithm right now to solve for just two of these pieces. Plus, they're not both going counterclockwise or both going clockwise. So now to use the other algorithm, which just rotates the corners in their place. Okay, so for that one to work, I want to have any one of the pieces I'm rotating to be on the top, front, and the right. This is the piece I'll be moving first. And right now I see this going counterclockwise. So the main sides I'm going to use in this algorithm is the right and the bottom sides. So I'm going to take this piece, and since it's going counterclockwise, I want to start with the right. So I'll do R inverted, D, R, D inverted, R inverted, D, R, D inverted, and I'm going to have to do that one more time. So R inverted, D, R, D inverted, R inverted, D, R, D inverted. And then once I've done that, I have to rotate the next piece over and do that one more time. So R inverted, D, R, D inverted, R inverted, D, R, D inverted. Now I solve for the shape, while also keeping this middle layer solved. Okay, so now the next thing to do will be to solve for these outer sides, so the orange face and the red face. So just this outer layer. And to do that, I'm going to take any side, the red or the orange, and I want to solve for the cross first. So I'll solve for the red, and to solve its cross, I see that one part of the cross, this red and green, is already on the red side. So rotating this to where it should be in respect to this middle layer, I see that one goes here. So the piece opposite, on the opposite side, should be red and blue, which should be over here. So I'm going to find the red and blue, which should be on the orange side. It's right here. And I want to put that in here. But I can't just turn it like this, because then that will mess up this middle layer. So what I have to do is, after I do this, I have to move it over to a different piece that's not solved and then rotate it again. Or, as I'm probably going to end up doing, I can start off with this not on this face I'm turning. So the piece I want to move in isn't going to be along this side. So I'm going to take the piece I'm going to swap it with and put that down to the bottom and then replace it. Now when I bring it up, this piece is solved and this middle layer is still solved. So I have two parts of my cross done, and I need the other two. So looking at the middle layer, since the blue is here, I need the red and white to be over here. That's here. So again, bring it down to the bottom and switch it. That one's done. Now last part. And my top cross is now complete. Okay, so from here there's several different ways of solving it. So what I did was I did the cross first. So in that case, I'm going to have to treat these two pieces as one corner piece and these two pieces as one edge piece for now, and solve like I would for a regular 3x3x3. However, if I started with the corner pieces first, then I'd have to solve like a 2x3x3 using slightly different algorithms. So since I did the cross first, I'll do it like a regular 3x3x3, except since I've already have this middle layer complete and I don't want to mess that up, I'm going to have to do it in a slightly more elongated fashion. So first I see that these two pieces, if I rotated these, one here and one here, then these two will then be solved since the red and blue goes here and this red and blue goes here. So one algorithm I can use for that would be to have the three pieces I'm moving, 1, 2, and 3, and they're going counterclockwise. So I want to have them in the front left, front right, and back right. And from here, the algorithm would be R, B, so it'll be R, B inverted, R, 2F, R inverted, B, R, 2F, and then 2R. And that would solve for these two pieces. So now my other two corner pieces are on the opposite side, so I have to get these over to here. And the best way to do that, well, there are several different ways you can do that. I can either change the shape again, so I can take these two as one corner piece and these two as one edge piece, and I can place them in here using the 3x3x3 algorithm for the last layer, and then rotate them into their correct position. Or I can bring this piece up to the orange side and then solve for this piece, and that piece, and then put it back down, which is what I'm going to do now. So I'm going to take this piece, bring it up to the top. Now the red and green is over here. And I'm going to take these two corner pieces and match it up with this edge piece. So I can see that since I'm using this side, the red and green is when the red and green is in front here, I know I need the red and green over here. So if I place this one here, then all I have to do is to move it down to the red side again, and then when I move this back over, then now connects. And then the same thing with this piece. So first I have to move it over to here, because right now I can't do much. So I'm going to move this down to the other side, then just change its position. Now from here, if I rotate it around, I can see that the red and green is over here. So when I have the red and green here, put it down to the red side, then connect them. So now these three pieces are connected. So now when I turn the side back, so I can solve the middle again, then my red side is now complete. And this doesn't usually happen, but it turns out that the orange side also managed to complete at the same time. So these next layers are the same. You pretty much solve exactly the same way as this orange and this red. So I'll get into those. I'll just skip how to solve this layer because it's going to be the same as if you solve these layers. Okay, so now I'm left with these two inner layers. And the first thing I want to do is to match up the corner pieces. So this piece, this piece, this piece, and this piece for one of the layers. because the edge pieces, since they only have one color, they might be on the correct layer or they could be on the incorrect layer. And the only way to tell is to solve for these these corner pieces first. So first I'll take this layer under the orange, and I'll see which corner pieces are already in their correct places. So I can see that this corner piece is in its correct layer. This one is not, since it's a blue here and a yellow here, while it's white. And I also see that this blue and white piece is in the correct layer, and this green and white is in the incorrect layer. So these two are good, but then these two are not. So the first thing I'm going to do is to rearrange these two corner pieces so that they're adjacent to each other, since it's blue here and blue here. So I have one piece back here and one piece over here, and the connecting color is blue. So I'm going to move this down to the other side. Then when I rotate this over, now my two corner pieces match up, and these two are now solved. So now I'm looking over here and I see this green and yellow and this green and white are still not solved. So I have to take the green and yellow and the green and white from down here. I have to connect them. Right now they're already connected by the green, and I have to replace them with these. So again, I can't just move it like this once to solve for these layers, because then this layer, and this layer are all messed up then. So I'm going to take the two pieces I'm swapping in and move them out of the way. Then when I take the two I'm swapping them with down to this layer, I have to rotate it once more to solve for this again. Before I do that, I'll put in the piece I'm swapping in, and now all my corner pieces are solved for this layer. And then again, this one managed to solve on its own the corner pieces, so I'll just go over what happens if that doesn't work out like that. So this is a situation when you have at least one layer like this where not all the corner pieces are in the correct places. Then there's an algorithm for switching two of the corner pieces. So what it does is it switches the two corner pieces that are on the right side, so these two, the one the right front and the one the back right. So if all of the corner pieces seem like they're incorrect, then you can start wherever, because no matter where you start, the two that are over here, once they're switched, will end up solving with respect to each other. But if you have a case like this, where two of them are already solved and two of them are not, then you should have the ones that are not solved yet to be on the right. And these two will swap, and then it will be complete. So I have these two on the right, and from here, I'm going to treat this as the top face, and this layer as a bottom face, since they are connected to each other. So this is going to be U, that's going to be U inverted. That's going to be D, that's going to be D inverted. So from here, with the two pieces on the right, I'll do 2R, U, 2R, U inverted, 2R, 2F, U inverted, 2F, D, 2R, D inverted. And that will solve for your corner pieces. Now the last thing to do is to solve for these edge pieces. Okay, so when I do this, I want to pick one side and completely solve that side first. So I'm looking over here, and I think this layer would be the easiest to solve, because the method I'm using will swap two opposite edge pieces from one layer into the two opposite pieces on the other layer. So in this layer, these two pieces are already solved, but one piece and this piece, so these two pieces are opposite of each other, but I can solve for those. On the other hand, this layer, the two pieces that are incorrect are adjacent to each other, and two pieces that are correct are also adjacent to each other. In that case, I can't use the method I was going to use, because then one of these pieces that are already solved will get messed up. So I see that on this side I have to put in a yellow and a white. So from the other side, I want to try to get a yellow and a white opposite of each other. So there's two whites here and one yellow here. So if I take these two pieces and swap them, then the yellow will be opposite of this white. So the algorithm to swap the front and the right edge pieces, treating this as U and this as D again, would be 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. And as you can see, that does swap these, but usually either they will end up solving because you would have to do this algorithm an even number of times, then this will flip back again, or to fix this, all you have to do is take any of these two edge pieces and just do 2R, 2U, 2R, 2U, 2R. And since that keeps them opposite of each other without switching them with their adjacent edge pieces, that wouldn't change how I solve it. So on this side I need this white and yellow to be over here. So what I'm going to do is take this yellow and white piece, I'm going to move it out of the way first. Then when I move this middle layer, flip it around to the other side, then now I can match this piece and this piece. And when I bring the middle layer back to where it was, then now this side is completely solved. Now that I'm looking at the other side, I see there's only two pieces left. But this is what you might consider a parity error, because the algorithm I used to solve for these two, as you saw, it rotated these three pieces, and then it wouldn't be solved anymore. And doing that algorithm one more time would mess up other edge pieces. So you might think this is a parity error. But the actual problem is, since these edge pieces, unlike what you would normally see on a regular 3x3, since they only have one color, for example, this blue and this blue might have to switch, or this yellow and this yellow have to switch, or this green and this green have to switch, or this white and this white have to switch. One of them, at least, is in the wrong layer. So all you have to do is to swap those two pieces. So I'm going to take these two green pieces and I'm going to swap them. So first thing I'm going to do is take both of them and put onto one layer. So I'll put them both onto this layer. So putting both of them over here, starting off with both of them in the same line, I'm going to rotate the middle twice. Now the other green piece is now here, but I have to move the middle layer again. So before I do that, I'm going to move it out of the way. So there's one green piece here, and when I move the middle back again, I have another green piece here. So from here, I had to swap these two. So all I had to do is use that algorithm once. So I have one in the front, one on the right, and swap these two. And then they'll be swapped. So from here, I'll do 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. And as you can see, this swaps this again. But since the only two pieces I actually changed other than these three layers is these two pieces, once I put it back as it was, so I'll put it back as it was before. So this is what it looked like before. Now that I've done that, I see that using the algorithm once to solve for these two pieces would also switch these three layers one more time, and now everything will be solved. So I have these two pieces left to switch with these three layers. So make sure that these three layers are on the right side, while the two edge pieces you're switching are on the front and the right. And from here, I'll do the algorithm one more time, So 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, U inverted, and 2R. And that's how you solve a 3x3x5 cuboid. Thank you for watching.